All right, so in today's lecture, I was about to start auto scaling group. So I thought let's first talk about the load balancer. That will be, you know, that will be a good idea, I believe. So we will be step by step learning everything. So let's talk about the load balancer. So first, let us understand what is the role of load balancer, why it is required. Now consider that you are having one EC2 instance or any machine, right? And consider this is your machine, okay? Or consider this is your EC2 instance for simplicity. And on this EC2 instance, you are running one application, and that this is your EC2 instance, okay? And you are running one application on it, which is a web application, which is running at port number 80. Okay. So I'm not taking complex application, but web application, which is running at port number 80, but it can be your application, which is running with the certificate or any complex application, whatever, right? So here it is running. Now, um, now here your web application is running and your client they are basically accessing this application. Okay, so they are basically accessing your application. So client is accessing this application. Now traffic is considered. It is 1,000 requests or maybe 100 requests. Let's take simple 100 requests concurrently coming to this system. Okay, so concurrently means simultaneously in parallel, those requests are coming to your EC2 instance to access your website, right? So, so according to that, you have set up your EC2 instances. Now, after some time, you realize that you need uh, more hardware, right, to support uh, these requests or concurrent request, or maybe the request so that whenever they are accessing your application should perform well. Application how perform well? So there is a concept which we call the latency. Okay. So latency is what? It is a request plus response time. So for example, if you are if you want to access a website, so you are requesting, the response comes from the server. So request plus response time is called latency. So it means if the latency is low, the performance is good. Now consider some of the users, they are complaining that your website is running slow. So can you make it fast? So you realized, okay, we are having 8 GB RAM and two CPUs on this EC2 instance. Let us increase the RAM capacity or the number of CPUs. So for that, what you are doing? You are doing is scaling. So this is called scaling. So scaling is a process where you can adjust the resources where your application is deployed according to the demand. Okay. So if traffic is more, so you are doing scaling. So scaling is of two types. Okay. So there are two types of scaling. So what is scaling? To adjust the hardware capacity, okay, as per uh, as per demand. Okay, demand means the traffic demand. Okay, so if now your client is saying, okay, some of the users they are facing a problem that that performance is not good. So what you have decided, you are going with the vertical scaling. I think this topic we have discussed earlier also, but I'm just trying to repeat this because this is required in our load balancer case. So vertical scaling is that basically you are doing scale up. So if you see somewhere scale up, it means we are talking about the scale, vertical scaling. Scale up means you are increasing or you are increasing the uh, hardware capacity, okay, RAM or CPU. And there is another term which is used, which is called scale down. In scale down, you are decreasing the hardware capacity. Decreasing means, for example, the the number of requests is now less. Maybe on weekdays you are having a lot of requests. So at that time you are, increasing the hardware capacity. But if it is weekend, the traffic is less. So you are saying, okay, instead of 16 GB RAM, I will make it 8 GB. So it will save the cost. So this is called vertical scaling. Second is called horizontal scaling. Horizontal scaling, what you are doing, you are basically doing a scale out. So scale out means you are adding the servers. Okay. So you are adding or you are doing a replication of your virtual machine. Okay. So you are adding a server. And when you add the server, right? So when you are adding the server, this is called scale out. So for example, there is a lot of traffic comes to your lot of traffic which comes to your machine. So you decided, okay, I will have one more machine or two more machine or maybe 100 more machines where the traffic is equally distributed so that client should not face a performance issue. My latency should be as minimum as possible. And same way, you can do a scale in, scale out and scale in. Scale in means you are removing the servers. Okay. So maybe the traffic is less at that time. You can you can remove the servers. And if you want to perform this activity automatically, there is a concept which is called auto scaling. Okay. So that we will discuss in detail, but um, but that is the one which we use for the horizontal auto scaling. Vertical scaling, you can do it uh, by uh, by adding or by changing the instance type. Consider you are running with the T2 micro and you want to increase the RAM or CPU. What you need to do? You just need to change the instance type T2 micro to T2 medium. So in that case, this is vertical scaling. But if you are adding new servers, that is called the horizontal scaling. Is this point clear to you?
Yes.
All right. So now, so this is so we are going to talk about the horizontal scaling in our load balancer. So now consider this is your EC2 instance, and same way you are having one more EC2 instance. Okay, so this is one more. So you have created a replicated EC2 instance. And what do you want? That whenever the traffic comes, it should be equally distributed to these two EC2 instances. And both the EC2 instances are running the same application. Okay, same, consider EC2 web here. So here also EC2 uh, web. So on this EC2 web. Now, instead of defining some custom method, AWS gives you the load balancer. Okay, load balancer of different type. We will talk about that. So what AWS gives you, it gives you a load balancer. So load balancer is what? Load balancer is basically uh, it is the one which is this is the one which is basically handles the request. So request will not go to your EC2 instance now. So now the request will go to, so this request not going to this, one second. So this request is not going to your EC2 instance directly. So it will not go here. Okay. So the request, it will go to the load balancer. So load balancer will have one public IP address. Okay. So you can have public, private. And this load balancer will transfer the traffic to these two instances. So these instances should be registered with the load balancer. So it means the request will go to this load balancer, and this load balancer will this load balancer what it will do, it will basically distribute the traffic to these EC2 instances, right? So this is a overall concept related to the load balancer, whatever load balancer we are using. So there are different types of load balancer in AWS. We will talk all in detail, but the main purpose, or in nutshell, if I talk about it, load balancer, its job is that to distribute the traffic to multiple EC2 instances, right? And for example, if load balancer have these two instances, and uh, still your client is complaining that we are getting low performance, so you will create one more EC2 instance here. Okay, so you can create one more EC2 instance and you can attach to this load balancer. Now, client need not to access with a new IP address or domain name. So client is basically accessing the application through load balancer. Now, load balancer internally having three servers now. So it means the traffic will be distributed to these three instances equally, and maybe four, maybe five, maybe 10, right? So it totally depends. So if I say you need to access google.com, okay, and you are facing some issue that performance is not good. Now google.com, they have considered this is a load balancer domain name. Okay, so this is called domain name .com .in, right? So this domain name is internally having one IP address. Same way, load balancer is having a domain name plus uh, means internally it is having one IP address. Okay, so domain name is configured with the IP address. So we mostly get the domain name, and IP address is maintained by the AWS. So now whenever the request comes, so request goes to the load balancer, and load balancer will see whether the traffic is equally distributed to these EC2 instances or not. Consider this is having heavy loaded and this is sitting idle. So next request will go to this particular EC2 instance instead of going to this system, right? So this way we can minimize the latency. We can, dynamically we can add the servers. We can um, give only single domain name or IP address to the client, and uh, with this way we can minimize the latency. Now, load balancer is in AWS. This is a software. It is not hardware. So load balancer is basically one is software load balancer, one is hardware load balancer in real time. If you are having your on-premises environment, your own data center, so you are having a hardware device which is a load balancer. But in AWS, we are not using the hardware load balancer. So internally, AWS may be using that hardware, but we are not using. We are just configuring our load balancer. Is there any question so far?
So here we are adding the servers, right?
Yeah.
In
So
EC2. Okay.
EC2 instances. So this is horizontal scaling. Okay. So we are
Hmm.
adding the server. So here actually, once we discuss the auto scaling groups, so these servers will be
Hmm.
automatically get attached. But initially we will see some EC2 instances, which is static EC2 instances, which are not growing automatically. But once we discuss the concept of auto scaling, after that you will see that EC2 instances are uh, automatically growing, depends upon the some metric. A metric means like if you say if the CPU utilization is more than 70%, then add a new server. So so that you can do.
Okay.
Okay. So we will learn everything step by step. First, we will see the baby steps of EC2 instances, how we can attach manually. Then we will see auto scaling. Right. So now, how you can see these load balancers. So there are different types of load balancer, and we will discuss all. Okay. So let me go to EC2 instances. So you can see the load balancer option here itself. Now here in the instances, here you can see there is a load balancing, right? So here you see load balancer, trust, stores, and target group. Let's click on load balancer. So here, whatever the load balancer you are creating, you can see it here. Now I'm creating a load balancer. Now there are different types of load balancer. First is the classic load balancer, which is a previous generation. So it is, a typical load balancer, which is basically what we are doing. We are just adding our EC2 instances to this classic load balancer, and there is an algorithm which is internally uh, defined in the load balancer, which equally distribute the traffic. There are some, different types of load balancer algorithms are there, depends upon which load balancer we are using. Consider there is a round robin load balancer algorithm. In round robin, basically what happens? For example, there are three machines. So first request go to machine one, then second request will go to machine two, then third to third machine, and fourth request again go to machine one, and then machine two, and so on. So this is one of the algorithm. Just I'm just explaining you, means our load balancer. It depends that what algorithms you are using, right? So here, if you see, this is a classic load balancer. Choose classic load balancer when you have existing application running on EC2 instance. So the example which I have explained to you theoretically, so this is a typical example of the classic load balancer. Here is a developer or your client who is basically accessing your application, and it is using this classic load balancer, and the request is related to port number 80, port number 443 means HTTP or HTTPS request, or it can be TCP request. TCP request means any port number. It is not necessarily port number 80 or port number 443, or it could be SSL related. SSL related means where we are having the SSL certificates. So this classic load balancer, it is tagged as previous generation. Maybe in future, AWS will remove it, but at this moment, it is available, right? So now, before creating this load balancer, what I will do, I will create two EC2 instances, and in those two EC2 instances, I will install some web application. Okay, so let me go to EC2 instances first. Right. So here I will go to instances, and I will create instance, which is I will call it as web one instance. Okay. And here I'm using this, you can choose any of this, right? I will select Ubuntu. Right? You can select AWS Linux also if you want. Instance type T2 micro. Key pair, I will select my key pair. And networking, I need to open the port number 80. So yesterday we have created all traffic. So I'm opening this all traffic. Okay. So means it will open the port number 80 also. Or if you want to specifically you want to set, yesterday we have created one more, all traffic web and SSH, right? Where port number 22 and port number 80 is open. Let's stick to this. Okay. Now here what I will do, I will go to the
Mm.
advanced, and in the advanced, uh, what I'll do, I'll come down here, and I will go to the user data and I will write a script, right? I'm not choosing a file. I'm writing a script. So this is Ubuntu. So I'll say hash exclamation slash bin slash bash, means I'm using bash terminal, and I'll say sudo apt update. Okay, sudo and apt install. I'm installing Apache on this machine, Apache 2 -y. And once Apache is installed, and then you will have one special directory where www and html. I think you remember that, right? So now I'm putting some file here. I'll say echo, and um, uh, I'll use the, I will change the host name also. I will say sudo. Um, um, I'll change the host name, that is host name ctl set host name. Mm, Actually, we need to run the bash command after that. We can do that. Okay, so let's do that. Host name, and I will call it as this is server one. Okay. Now, after that, I need to run the bash command, sudo bash. Now I will say sudo and echo, and I will say h1, right? Or I'm not setting this host name because I will create two machines together. Okay, so that is okay. So now I will say h1 and I will say dollar host name. So two machines will have different file, right? Because their host name is different, and slash h1. Okay, and I want to put it under slash var slash www and html, and I will call it as index.html file. Okay, so I want to create two machines with the same configuration. Okay, and I will say launch instances. Now, if I go to my instances and if I refresh this here, so this is web 1 and I will call it, this is web 2. Right? Now, I want to check whether my application is deployed or not. To do that, what you need to do, take the public IP address, because we have opened port 80 and port number 22 to everyone. So I will just copy this public IP address of this system and I'll paste it here. Okay, so this is not opening. We'll open in a Cognito window. So I'll go here and open in the Cognito window. So I will put it here. Okay, continue to the site. And okay, still it is, yeah. So this is my first machine IP address. That is what I have written, echo host name. Now, same way, if I check my web server 2, right? So here I'll take this public IP address. See, here it is 982, which is nothing but, that private IP address by default, that is the host name. Now, if I check this one, it will have different host name, right? 112. So if you see here, this is 112 and this server is, in real time, you are having same application, but I'm putting two different, you know, uh, different application so that we can see that whether our request is going to these two servers or not. Okay, that is why I'm putting uh, two different these servers. So basically, uh, what I have done so far, so I'm having so at this moment I'm having this server 1, this is server 2. Okay, in real time you are having the same application, but at this moment I'm having two different applications with different content. So here we are having these two machines, right? Now now I will create one load balancer, and that load balancer will send that traffic to either this machine or to this machine, depends upon that uh, algorithm which it is using, and it always try to maintain the uh, traffic which is on these two systems. So if a request comes, so request will come to this load balancer, and load balancer will transfer or route that request to this EC2 instances, and it is using its own algorithm to decide on which machine it will go. Okay, so now uh, we will go and create a classic load balancer. So we will discuss all the load balancer uh, in our upcoming classes, but today we will discuss about the classic load balancer only. So I will go to my machine here, and I will go to the load balancer. So here you can see the load balancer, and we'll create a new load balancer. Now in this load balancer, classic load balancer, and in classic load balancer, we will create a load balancer. So here the load balancer name you can give anything. So you can say, uh, I'll say classic load balancer 1. Okay. Now it is saying how you want to use. You want to use on the internet, means internet facing. So it will have one public IP address or DNS name. Okay. And which will resolve our EC2 instance public IP addresses, right? Or IP addresses. And it requires a public subnet. Okay. So these are basically related to VPC, means we should have a public subnet, uh, and VPC we have not discussed, but this is for the internet. So public subnet, where the internet gateway is attached to your subnet, which provides the internet connectivity your to your subnet machines. So here it is saying, so you need to decide at this moment while creating whether internet facing or you want internal traffic, means it will have one IP address which is private or DNS name to the private IP addresses. So I'm going with the internet facing. Okay. And which VPC? VPC is same. Now it is saying from where it will pick up the machines. So our machines are basically created in EC2 instances. So consider your EC2 instances are spread across multiple availability zones. So which machines you want to attach to your load balancer? So you need to select those machines availability zone. So I don't remember. So I'm selecting all. Okay, because I want from all the availability zone, it will pick up the machines. See, that subnet is getting attached automatically. All right. Now, after that, you need to give the security group. So I'm giving a security group, which is you can select all traffic or web access, because I'm going to access my load balancer at port number 80. So I will select all traffic. Okay, there is one default is already there. If you want to remove, you can remove it also, because now we are giving the all traffic. At which port number it will listen? Because my application is running at port number 80. So I will give the port number 80 to my load balancer also. It is not necessary you should have the same port number as your EC2 instance port number, but I'm giving port number 80 because that is a default port of HTTP, but you can change anytime. If you want to add one more listener means it's a process to check the connection request using protocol, right? And port you configure. So it will be listening HTTP protocol at port number 80. Okay. And now this is your EC2 instances. So EC2 instances port number is also 80 because our EC2 instance is running the application at port number 80. Right. Now it is the health check. What is health check? How it will know that EC2 instances are healthy, which are attached to the load balancer? So what it will do, it will ping at port number 80 and it will check I'm able to access index.html file. If it is able to access, it means these are healthy. Okay. So your load balancer automatically performs the health check to test the availability of the registered instances. Traffic is only routed to the healthy instances, which is determined by their response from the health check. Now there are some advanced settings. So you want that when I ping to this EC2 instances, so response time should be within 2 seconds. That you can increase or decrease. So minimum is 2, maximum is 60 seconds. What is the frequency you are checking that health check? 5 seconds to 300 seconds. Every 5 seconds, it will go and check the health of my EC2 instances. Unhealthy. If there are two consecutive health checks, um, you know, if you find two times, I found my EC2 instance is dead. So it means it is unhealthy. And healthy threshold. Threshold means maximum limit. So the number of consecutive health check process, success before declaring it is healthy, 10. Means 10 times if I get the response in consecutive way, so it means my EC2 instances are healthy. Now here what you can do, you can attach your instances. So I'm attaching the instances, both the instances, web 1 and web 2. Okay. And you can say confirm. So two instances are running. Now, these things we will keep as it is. Timeout also 300. Now, we will create the load balancer. Right. So now the load balancer is getting created. And this is a feedback form. We will leave it for now. Refresh. Now, here you can see there is one load balancer get created. And that is the load balancer. And now here there is a DNS name. So with this DNS name, we will be accessing our EC2 instances. Now, what are whether the EC2 instances are healthy or not? How do you check? Just check this. And here you can see the target instances. In the target instances, currently it is showing out of service because still it is checking, okay, whether the instances are healthy or not. Once these are in service, then we can use this DNS name and we can go here and uh, paste our DNS name here. So at this moment, because instances are out of service, so once they are in service, so we just need to refresh it, right? So now both are in service. In service, so it means now if I send my request, so let's wait for this, or maybe we will use the Cognito window. It should work here also, but let's open in the Cognito window. So if I go to this Cognito window and I give this uh, my DNS name, so it takes little bit time actually to show. Let's wait for that. So it is still trying. So if I go here, so both are in service. So that is correct. And okay, refresh it once. So my request should go to the load balancer and load balancer will route that traffic to my EC2 instances. Meanwhile, it is getting up. Any question you have?
No, not just clear.
Okay. So if it is not coming up, there could be a reason that security group may be a problem. We'll check our security group once. So this is our load balancer, right? You can go to security group. Let me check that security group inbound rule. So if I see the inbound rule, all traffic, and it is to everyone. So this is perfect. Outbound traffic is also fine. all traffic. Okay, it should work in all these cases. So not sure why it is taking that much time. Okay. So actually we have opened at port number 80, so it should not be HTTPS, it is HTTP. So now you can see this is my instance. Now if I refresh, see the request is going to both the servers, right? So load balancer is sending the request to both the servers now. So I have deployed two different kind of application, but in real time it will be one application. Is this point is clear to you?
Yes.
You can draw a picture in your mind that my request is going to load balancer. So
Hmm.
let me just quickly summarize this. So here uh, I'm using this load balancer IP, and load balancer, which is a classic load balancer. So this having a DNS, so this is the DNS of my classic load balancer, and the request is going to my EC2 instance, EC2 instance 1 or EC2 instance 2. Now, if you have one more instance, just attach to your load balancer, and then the request will go to the EC2 instance 3 also, right? So this will basically helps to load balance your traffic. Okay. So for today, that's it. And tomorrow we will see the application load balancer, network load balancer, gateway load balancer. Maybe in next coming lectures we will see that. All right.
Oh,
Thank you very much. See you in the next lecture. Bye bye.